Hi students, so in this lesson we're going to be solving radical equations. And on the side here I just wrote the process that we're going to be using to solve these. So the first thing that we're going to do is isolate the radical, then we'll square both sides, then we can solve for x and we'll have to check our solution. I'll show you what I'm talking about here. So if you have a problem that says solve the square root of x minus 4 minus 2 equals 6, for example. Okay, you have this radical here. You basically, solve this just like you would any normal equation, okay, where you're trying to get x by itself. What we want to do first is isolate this radical, this square root part. You want to get this by itself. Right now I see here I've got a minus 2 over here. I need to get that to the other side because I just want the radical on the left side. So first what I would do is add 2 to both sides. I would do that. And then that will isolate the radical. So I'll have the square root of x minus 4 equal to 8. 6 plus 2. Now that I've isolated the radical, now I can undo the square root by squaring both sides, okay? So square and square root, they're inverses of each other, just like adding and subtracting are inverses of each other. So you can actually square both sides to undo a square root. So I square both sides of this. That's going to undo that square root. And then it'll just leave me with what's left underneath. So I've got x minus 4 underneath. And then 8 squared is 64. So I do have to square both sides. Whatever you do to the one side, do to the other side. Now I can do that third step, which is solving for x. So I want to get x by itself. I need to add 4 to both sides. And so if I do that, I get x equals 68. So now at this point, I do want to check the solution, okay? Normally, some of the equations you don't have to check if you're really confident that you did all the steps right, but on these you definitely want to check because squaring both sides of an equation sometimes generates an equation that has roots that are not roots of the original equation, and we're going to see that on a few of these examples. So what we want to do again is check. So go back to the original equation and you're going to plug in your answer and make sure that the left side equals the right side. So we say, okay, here we go. Square root of 68 minus 4 minus 2, does that equal 6? So 68 minus 4 is 64. Minus 2 equals 6. Square root of 64 is positive 8. So move this up. Is 8 minus 2 equal to 6? Yes, it is. So that one's okay. Okay, so you can check that one. You will see, though, that a few of them, they end up giving you some interesting things when you try to square both sides. So I'm going to go actually... we'll do one more of these, and then I'm going to show you one that definitely needs to be checked. So for this next one, I'm going to do example 2. And this one is x plus 4 plus 2. And then this equals negative 7. So they just switched it up a little bit. So again, the first thing we want to do is isolate the radical. That means we need to get the radical part by itself. So you need to subtract 2 from both sides because we have an addition of 2 here. We need to undo that by subtracting 2 from both sides. So do that. And then we'll get the square root of x plus 4 equal to negative 9. This is interesting right here, actually. You can kind of see at this point, we'll see. If we can square root something and get a negative 9, that might be a problem there. So what we do is we've isolated the radical, now let's square both sides. So we're going to square both sides here. Don't forget you're squaring a negative 9, so that's going to be a positive. So we'll have x plus 4, because that square undoes the square root, and then we'll have 81. Now what we need to do is get x by itself, so subtract 4. Okay, and when we do that, we're going to end up getting x equal to 77. Let's check our work. Let's plug that back into the original. So if we plug it back into the original, look what happens. This is 77 plus 4 plus 2 equal to negative 7. So the square root of 77 plus 4 is the square root of 81 plus 2. Is that equal to negative 7? Square root of 81 is 9. 9 plus 2 equal to negative 7. 9 plus 2 is 11. And look, we have a problem here. Those are not equal. So already we've seen one where, the left side does not equal the right side. So on this one, we would actually say there's no real solution. So now I'll do one more, and this next one has a lot of steps actually. I'm going to come over to the side here, so I don't have to flip the page. And I'm going to do one that's very interesting because you end up having to square the variable this time. So on here, this is example 4. This is x squared plus 2x plus 13, all underneath that square root, minus 3 equals x. So again, the first thing we want to do is isolate this radical. So we're going to have to add 3 to both sides. So we add 3. We get this big thing again, this square root of x squared plus 2x plus 13. That cancels. We get x plus 3 on the right side. Now we have to undo this square root by squaring both sides. So this is going to be very interesting this time. Instead of just squaring a number, we end up having to square a binomial here. Oops, I just wrote a 3, I meant a 2. So we have to square this binomial, which means we have to use FOIL. Okay, so if you want to rewrite this on the side, maybe you can write it as x plus 3 times x plus 3. You could do that and try to figure out, okay, what would be first, outer, inner, last. You're going to need to use FOIL on that, right? So that's what we're going to do. So again, the square cancels the square root. We're left with what's inside here on the left. And then we're going to square this using FOIL. That's going to be x squared plus 3x plus another 3x plus 9. And so after this, we want to try to combine these together, combine the like terms. So we'll have x squared plus 2x plus 13 equals x squared plus 6x plus 9. And then we're going to try to solve for x. Now you're going to see if we try to get, let's try to get everything on the left side. Okay, so if I do that, I'm going to subtract the x squared from both sides. And those all cancel, which is great. So now I have 2x plus 13 equals 6x plus 9. So on this case, again, I'm going to just do it on the left. I'm going to try to get the variable on the left, but you don't have to do that. If you were to get the variable on the left, you'd want to move this 6x over to the left side. So you're going to subtract it. You're going to get negative 4x plus 13 equals 9. Then you're going to subtract this 13 to the right side, right? Subtract on both sides, but it moves it to the right. Negative 4x equals negative 4. And then finally, divide both sides by negative 4. Oops. And you get x equals 1. Don't forget, go back and check it. into the original equation. The original equation was x squared, so I'm going to do 1 squared plus 2 times x, so that's 2 times 1, plus 13, and then it was minus 3 equals x, and remember x is equal to 1. Sorry to slide that back up. So now we're checking this. We're plugging in the 1 into the original equation. So this is going to be 1 plus 2 plus 13 minus 3 equals 1. So 13 plus 2 plus 1 is 16. And square root of 16 is 4. Is 4 minus 3 equal to 1? Yes, it is. So you're good. So just remember to follow the steps, okay, that we had. Try to isolate the radical first, then square both sides to undo the square root. Then you can solve for x, and don't forget, check that solution.